Welcome to Data Engineering with Subadip. Today, we are diving deep into a fundamental concept in Python, the _init_.py file. You might have seen it in your Python projects, but do you truly understand its power and purpose? Let's unlock the mysteries of Python package power. In short, the _init_.py file is crucial because it declares a folder as a regular Python package. Without it, Python would simply see a directory full of files, not a structured package ready for importing. It is the secret handshake that tells Python, hey, this folder is special, it is a package. What happens when you add code to _init_.py? Any code you place inside this file gets executed automatically the very first time its containing package is imported. This makes it a prime location for initial setup tasks, defining package-wide variables, or even importing submodules to make them directly accessible from the package itself. So, what happens if you skip adding an _init_.py file? Before Python 3.3, its absence meant a directory was not recognized as a package at all. However, from Python 3.3 onwards, implicit namespace packages were introduced. A directory without an _init_.py can still be imported, but it is treated as a namespace package. This means it cannot contain an _init_.py file itself, cannot define _all_ for explicit exports, and critically, it cannot execute any code upon import, unlike a regular package. So, what kind of code should you put in _init_.py? You can expose submodules, making frequently used components directly accessible for easier imports. It is also excellent for defining package-level constants or variables, like version numbers. You can perform initial setup or logging configurations, but keep this minimal to avoid unexpected side effects. Finally, it is the place to define _all_, controlling what gets imported when someone uses a wildcard import like from my_package import all. When does _init_.py get executed? The code within _init_.py runs the very first time its containing package or any of its submodules is imported during a Python session. Importantly, it is executed only once, regardless of how many times the package is subsequently imported. This efficient behavior is thanks to Python's built-in module caching mechanism. Let us look at a practical example. Imagine you are building a data engineering library named mydatalib. In its _init_.py file, you can import submodules like connectors and transforms, making them readily available. You can also directly expose a frequently used utility function, like clean data, so users can import it simply as from my_data_lib import clean_data. Additionally, you can define package-wide constants such as the library's version. This structure significantly simplifies imports for anyone using your library. Can you use _init_.py to control what is exported from a package? Absolutely. By defining the _all_ variable within your _init_.py file, you gain precise control over which names, such as functions, classes, or variables, are imported when a user performs a wildcard import. This is a powerful mechanism to explicitly define your package's public API, preventing accidental imports of internal components and promoting clearer code organization. Is a top-level _init_.py different from one in a subpackage? Yes, they function similarly, but at different scopes. A top-level _init_.py defines what is directly available under the main package name, often handling versioning or global configurations. It is executed first when the main package is imported. A subpackage _init_.py, on the other hand, controls imports and exposes names specifically within that subpackage's scope, and is only executed when that particular subpackage is imported. Essentially, each _init_.py acts as the entry point for its respective package or subpackage. In conclusion, the __init____.py file is a cornerstone for well-structured Python projects. It transforms simple directories into importable packages, provides a crucial point for initialization logic, and offers fine-grained control over what is exposed to users of your code. Mastering its use is key to building maintainable and scalable data engineering solutions and Python applications. Thank you for watching. I hope this deep dive into Python's __init___.py file was informative and helpful. For more data engineering insights and tutorials, be sure to subscribe to Data Engineering with Subhadeep. See you in the next video.